1.3.2 X.500, the directory service standard. However, the OSI protocols did address issues important in large distributed systems that were developing in an ad hoc manner in the desktop and the internet marketplace. One such important area was directory services. The CCITT created the X.500 standard in 1988, which became ISO 9594. Data Communications Network Directory. Recommendations X.500, X.521 in 1990, though it is still commonly referred to as X.500. X.500 organizes directory entries in a hierarchical namespace capable of supporting large amounts of information. It also defines powerful search capabilities to make retrieving information easier because of its functionality and scalability. X.500 is often used together with add-on modules for interoperation between incompatible directory services. Note, an excellent online resource on X.500 is the book Understanding X.500, the directory. While dated 1996, this book, which is now out of print but available online, is considered one of the original gospels of the directory world. It describes and defines the X.500 directory model in great detail. Much of the material is still very much relevant in today's current family of LDAP directory service. It can be found here. http://www.isi.salford.ac.uk/dwc/x500.htm. X.500 specifies that communication between the directory client and the directory server uses the Directory Access Protocol DAP. However, as an application layer protocol, the DAP requires the entire OSI protocol stack to operate. Supporting the OSI protocol stack requires more resources than are available in many small environments. Therefore, an interface to an X.500 directory server using a less resource-intensive or lightweight protocol was desired. 1.3.3 Lightweight access to X.500. LDAP was developed as a lightweight alternative to DAP. LDAP requires the lighter weight and more popular TCP/IP protocol stack rather than the OSI protocol stack. LDAP also simplifies some X.500 operations and omits some esoteric features. Two precursors to LDAP appeared as RFCs issued by the IETF, Directory Assistance Service, RFC 1202, and Dixie Protocol Specification, RFC 1249. These were both informational RFCs, which were not proposed as standards. The Directory Assistance Service DAS defined a method by which the directory client could communicate to a proxy on an OSI-capable host, which issued X.500 requests on the client's behalf. Dixie is smaller than DAS, but provides more direct translation of the DAP. The first version of LDAP, Lightweight Directory Access Protocol, was defined in X.500 Lightweight Access Protocol, RFC 1487, which was replaced by Lightweight Directory Access Protocol, RFC 1777. LDAP further refines the IDs and protocols of DAS and Dixie. It is more implementation neutral and reduces the complexity of clients to encourage the deployment of directory-enabled applications. Much of the work on Dixie and LDAP was carried out at the University of Michigan, which provides reference implementations of LDAP and maintains LDAP-related web pages and mailing lists. RFC 1777 defines the LDAP protocol itself. RFC 1777, along with the string representation of standard attribute syntaxes. RFC 1778, a string representation of distinguished names. RFC 1779, an LDP URL format. RFC 1959, a string representation of LDAP search filters. RFC 1960, defined the original LDAP version 2 version of the language. LDAP version 2 has reached the status of draft standard in the IETF standardization process, one step from being a standard. All of today's directory server implementations are based on LDAP version 3 specification. LDAP version 3 is defined by Lightweight Directory Access Protocol, version 3. RFC 2251 related RFCs that are new or outdated for IDP version 3 are Lightweight Directory Access Protocol.